In this video we're going to talk about complex expressions, and complex expressions are ones that involve the number I in your expressions. Now remember that I is equal to the square root of -1, and thusly I is a square root. So remember that when you were doing algebra with rational functions and you had all kinds of other things going on, you always had to rationalize things that had roots in the denominator. By the same logic, if you have I in a denominator, you can't leave it there because it is really a root. So you need to rationalize. So let me give you an example here. And we had 5 over I. And we said we have that expression. This is not rationalized. You can't leave your answer this way because I is a root. So we need to multiply it by something that would get rid of that root. We could multiply the top and bottom in this case by I, because if I is the square root of -1, I times I is I squared, and I squared is equal to -1, so that would leave us here -5i, because we have 5 divided by -1. This is the rationalized version of that. So you can never leave i's in the denominator. Similarly, so this is just multiplying by itself in order to get rid of the root. The other way that you rationalized expressions when you had real things in their roots was by doing the conjugate. And the conjugate is if you had something like this. So again, this isn't rationalized because we have an I in the denominator, but we can't just multiply by I to get rid of it. We have to multiply by the conjugate, and in this case, that's the complex conjugate. 2 minus I, 2 minus I. Remember that to do the complex conjugate, or any conjugate, you always reverse the sign that's attached to the complex part of your expression. So here, on the top, we can distribute this 5 and get 10 minus 5i. On the bottom, whenever you multiply by the conjugate, you always get the first term squared minus the second term squared, which in this case is I. So here you can see we get 2 squared, which is 4, minus I squared is -1, so we get 4 plus 1, which gives us 5. And finally, we can reduce everything here by 5, and we get 2 minus I. So 2 minus I is equivalent to 5 over 2 plus I, but this is the rationalized version. So that's how you go about rationalizing things with i's in the denominator. There's another couple properties of I that are handy to know. First of all, I is cyclic around powers of 4, and what that means is, let's take a look at raising I to higher and higher powers. Well, I itself is the square root of -1, and if we square it, as we've seen a couple times here, you get -1. So let's take the next couple powers of I squared is equal to -1. I cubed. Well, I cubed is just multiplying this by I. -1 times I is just going to be -I. And finally, I to the 4th. You can either think of that as -I times an additional I, or you can square I squared, because squaring something that's squared gives it to the 4th power. -1 squared is +1. So we've returned back to 1, and then you can see if we were to go any further, I to the 5th is just 1 times I, which is back to I. So I just rotates around these 4 values for I to the 1st, I to the 2nd, I to the 3rd, and I to the 4th. So what that means is if you have a very large power of I, you can always reduce it by factors of 4. So let's say we had I to the 101st power, and you wanted to simplify that. Well, I to the 100 times I is the same thing as I to the 101. And I chose 100 because 100 is a multiple of 4. You can see here, every time we get 4, it resets and we would keep going back. So if you have a multiple of 4, this is simply 1. So if your power of I is a multiple of 4, you always just get 1. we're left with 1 times I, which is I. So that tells you that I to the 101st power is actually just I. The last thing you can do with complex expressions excuse me, is let's say you had something like square root of negative 15 times the square root of negative 10. Now in the real number system, this doesn't work because you can't take the square root of negative numbers. However, we know this is the same thing as the square root of negative 1 times 15, square root of negative 1 times 10, using the complex numbers, and the square root of negative 1 is I, so this can be factored out of both of these. Now we can group the i's together at the beginning and get I squared, and now if you just have root 15 times root 10, that is simply root 150 because you multiply those together. So it's important to note that you can't do that at the beginning, because you would see here, if you just multiplied negative 15 times negative 10, you'd also get 150. But you're not accounting for the fact that these are complex numbers. So you have to take the I out first. You get negative root 150, because I squared is negative 1. And then we can try to factor this further. 150 is 25 times 6, and 25 is a perfect square. So we get here that this is negative 5 radical 6, and that's as simplified as we can get that. So we've covered all kinds of things here in complex expressions, how to simplify complex expressions, how to rationalize them, what a complex conjugate is, about the circle, or the cycle you could say, of powers of I, and finally how to do some arithmetic with complex numbers. So most of this stuff is conceptual in nature, but the mathematics of it is not anything you haven't done before. You're just going to have to get used to the notation, and for example these things like the cycles of I, and just treating I as radical when having to simplify expressions. But that's everything you're going to need to know about complex numbers.